reasons. All right, so what I was saying before I was so rudely interrupted was to add or subtract fractions, you need a common denominator. That's not new for you guys. We didn't need a common denominator to multiply and divide, but we do to add or subtract. But look, in A, hey, these two fractions, 5/7 minus 3/7, we're just good to go. There's a common denominator. We just do, I'm even going to show an intermediate step. You just subtract the numerators, keep the bottom the same. Would you look at that? 2/7. Hey, it's adding, subtracting fractions. You just need a common denominator. Should sound familiar. In part B, we do not have a common denominator. In order to add these two fractions, they must have a common denominator so that we can add them. So we take one or both, and we write an equivalent fraction. Kemper, do you just want to grab that extra desk back there, wheel it around behind Jaden? So I think maybe you can focus better, okay? Right, congratulations, you're YouTube famous today. In this particular case, we only have to change one of these fractions to get a common denominator. We can change 3/2 and write that as an equivalent fraction over 6. 3/2 is the same as 9/6. Why 9/6? Add this if you want to. I'm not your dad. But to make 2 into 6, we multiplied by 3. We also need to multiply the top by 3. We find a common denominator, and we get 14/6. 14/6 is fine. But we can write that in lowest terms, 7/3. It's adding, subtracting fractions. If this is something you're already comfortable doing, that I apologize. I'm just trying to get everybody up to speed. But also, these same ideas we will be using in a second, but with rational expressions. Look at C. I can't multiply 3 by any convenient number to get 7. So what do I do to get a common denominator? You guys know this little trick. You could just multiply the denominators together to get a common denominator that works. 3 times 7 is 21. I'm going to have a sip of coffee while you guys make those two fractions, equivalent fractions over 21, and add them together. Now, as you guys do that, any scientific calculator these days has a fraction button, and you could just do this on your calculator, and it will spit out an answer. But we're using these techniques today to add or subtract rational expressions. That's why we're reviewing these ideas. 2/3. We got to multiply 2 by 7. 14/21. And 4/7 times 3 times 3, 12/21. I'm getting 2/21. How about you guys? 2/21? Hey, it's adding, subtracting fractions. Can you guys try the last one? If you can't see a good common denominator, there is absolutely nothing wrong with just multiplying the denominators together. And in fact, that is what I'm going to do. Even though there is a lower common denominator than 60, it's okay. Let's just use 60. Let's multiply those denominators together. So what's that? 50/60, and 10 times 6 is 60, so 18/60. 32/60, and in lowest terms, divide by 2, divide by 4, 8/15. Hey, if you guys did a common denominator of 30, that's fine. You'd have 25/30 minus 9/30, which is 16/30. And in lowest terms, it's 8/15. Okay? So this is our crash course review in adding, subtracting fractions. I can't apologize for the fact that it's in this 3U math course. This is just a skill you should already have in the toolbox. But I have done you guys the favor. We have reviewed a little bit these ideas, so now we can apply them to rational expressions. So having done that little mini review, let's dive in to our first few examples. Kind of like I would call these level 1 problems. Let's look at A. We're adding the two rational expressions, 1 over x and 2 over x. To add fractions, rational expressions, we need a common denominator. Guys, do we have a common denominator here? We do, which is good. That just means we just add the numerators together and we are finished. Life is good. 1 over x plus 2 over x is equal to 3 over x. They are equivalent expressions, except for one tricky value of x. What value of x would make these expressions undefined? 0. Remember, we always have to look at what makes the bottom 0. 1 over x and 2 over x always equals 3 over x, except when x is equal to 0. We have to keep stating those restrictions. Let's look at b. Oh boy, x plus 1 over x plus 3 and x plus 4 over x plus 3. We're adding these together. We're just applying those skills we already have. Do we have a common denominator? Nod and smile. That just means you add the tops. Collect like terms, time travel back to Miss Answers' grade 9 class, or mine for some of you. And let's just combine the like terms. I'm going to show an intermediate step here. You can if you'd like. I'm not your dad. But on the top, we're just going to add x plus 1 and x plus 4 together. We're just going to add those two. The common denominator stays the same, just like adding fractions. And we get x plus x is 2x. 1 plus 4, last time I checked, is 5 over x plus 3. Those two expressions are algebraically equivalent, except at one specific x value. You guys see what it is? -3. We ask what makes the bottom 0. This original expression, this bottom expression, equivalent in every way, except when x equals -3. You guys can do this. Look at C. C is very similar. We're just subtracting those two rational expressions. Just like B, we proceed by subtracting the tops this time. So we'll do x plus 1 minus x plus 4. Note how I'm keeping the x plus 4 in brackets. Just like in grade 9, where you added, subtracted polynomials together. It's the same idea. This time we're subtracting. X minus x, 0. 1 minus 4. So just make sure, I might even add this visual to make sure you guys are subtracting the 4. But 1 minus 4 is equal to -3. We get -3 over x plus 3. And again, x can't be -3. Can you guys try D? Can you guys give D your best go? The denominators are identical, so you can just subtract the tops. Just give it a try. Do it lightly in pencil. I'll do it in like 20 seconds, but just give it a try. It's already a common denominator. You can just subtract the tops. All right, I will come along for the ride. I will show this extra step. We are just doing 1, and we are going to subtract x plus 1. The denominator is okay. X plus 2, common denominator. Let's collect like terms. 1 minus 1 is 0. And we're just left with, remember we're subtracting, we're just left with -1x over x plus 2. With a restriction, x can't be equal to -2. Hey guys, it's adding, subtracting fractions, it's common denominators. We can all do this. I believe in you guys. All right, let's add our first little wrinkle. X minus 2 and 2 minus x. For you people, are those common denominators? Are those the same? They're not the same. But you know what? We can use a clever little algebraic trick to make them common denominators. And then I'm going to show you what I mean over here. Let's look at it this way. Guys, what's 5 minus 4? 1. What's 4 minus 5? It's not 1. What's 4 minus 5? It's -1, right? Same number, different signs. Let's reinforce that idea. Let's pretend we're on Barney the Dinosaur. What's 7 minus 3? That's 4. If we change the order of subtraction, we get -4. So here's the idea, guys. Here's the property we're illustrating. So please jot this down. Andrew, you want to dial in here. Jason, you work on your stuff and don't distract them. I only have so many desks to separate people. Here's the big idea, guys. 2 minus x is just the negative of x minus 2. When you change the order of subtraction, it just changes the sign. So check this out. What we can do is our first term, x plus 1 over x minus 2, we'll leave it like that. I can change this addition to a subtraction by changing the order of the denominator on the bottom. These are equivalent problems from this property here that we just talked about. And now this is literally a copy and paste of C. Can you guys give it a try now? The denominators are common denominators, and you can just subtract the tops. Give it a try. I'll wait 30 seconds, and I'll come along for the ride. And then we'll go on to level 2. You want to be super dialed today. I told you guys to eat your Wheaties and take your multivitamins and say your prayers this morning. This is the most complex algebraic skill we do in this course. So we've got to be super dialed today. Even more dialed than usual. All right, here I come. We're going to subtract the tops. We're going to subtract x. We're going to subtract 4. X minus x is 0. 1 minus 4 is -3. -3 over x minus 2. What's our one restriction? Flash me a gang sign with like our restriction here. Yeah, okay. X can't be equal to 2. Don't actually do gang signs. All right, level 1. Everybody seems happy and jovial and giggly. We feeling good? All right, let's crush some spirits and move on with the next level of problem. Here we go. All right, 3U people. So I kid, but we really do need to dial in. I'm not exaggerating. This is the toughest algebraic skill of the course. We ramp up quickly, so let's make sure we're super dialed. 1 over 2x and 3 over x, do they have a common denominator? They do not. Can we force them to have a common denominator by maybe rewriting one of them? I see a lot of people nodding. How can we do that? Forrest? Let's times the one on the right, top by 2, bottom by 2, and then they have a common denominator. Just like we're adding fractions together, you can multiply a fraction by a number and find an equivalent fraction, so you can add them. So I have the luxury of different colors here, and I might start mixing in some different colors. But I think here I can probably just say, hey, let's take Forrest's advice and multiply by 2 and multiply by 2 and reframe this question as 1 over 2x plus 6 over 2x. And hey, life is good, common denominator. Let's just add the tops. If you guys are okay, I will go right to 7. 1 plus 6 is 7, in case you didn't know. Of course, we are in the habit of stating restrictions. This is true as long as x is not equal to 0. That's not so bad, right? Change one of them to have a common denominator. Let's look at b. Anybody see how we could match the denominators up in b? Maybe someone who hasn't helped out yet today? Just keep doing this until we get a volunteer. How can we match these two? Here. X and x squared. I'd love for them to be common denominators. Colette?
Times the left fraction by x.
Yes. If we multiply by x on top and x on the bottom, we will have x squared on the bottom, and we have a common denominator. So let's take Colette's advice, and I'll multiply, might do the top by x and the bottom by x, x times x, x times x. It's not necessary to kind of write those little notes in, but yeah, we can write an equivalent expression, x over x squared plus x plus 4 over x squared. And now we can add the tops. X plus x is 2x. And the 4 has no friends to be collected with, so it's just 2x plus 4 all over x squared. Hey, look at us, guys. Look at us. We just did another one. Of course, x can't be 0. That would make the bottom 0. You guys see how we can make the denominators in C equivalent to each other? I think I heard it. Brian? Times it by 2. Now, this is the first one where I'm going to give you guys this new strategy. You're absolutely correct, and that will absolutely get you the right answer. But at this point, moving forward, sometimes our expressions on the top and bottom, to recognize what we can use for a common multiple, we might have to factor. And you guys have the idea. 2x plus 6, we can actually divide out a 2 there. So we're going to start tying in this initial step. Sometimes we have to factor first to get a better picture of how to move forward. So I'm just rewriting the problem, but on the right-hand term, I'm just going to factor the bottom. I can factor that as 2 times x plus 3. And now it's crystal clear, as Ryan said. How do we make the left side match the right side, the denominators? We just need to multiply it by 2. And that's what we'll do here. So we'll multiply 8 by 2. I'll mix in a different color here. And we'll multiply the bottom by 2. And what does that look like? Well, we get 16. And on the bottom, I'm going to leave it as 2 times x plus 3. I'm actually just going to write that a bit smaller to manage my space. Make Miss Plattner proud of me. Do not have mommy issues. Miss Plattner's not, she's my math mom. I guess that joke kind of fell flat. She worked here for a long time. Do you guys remember Miss Plattner working here? No? Okay. Note to self, don't use that joke anymore. All right, guys, we are basically done. Look, the denominators are the same. We can just subtract the tops. 16 minus 5 is just 11. Look at us. We just did another one. I don't have mommy issues. I have a healthy relationship with my mom and my friend, Miss Plattner. Just a joke, lighten up. And of course, x can't be negative 3. That makes these expressions undefined. Hey, we're happy. Life is good. You guys doing okay so far? So far, so good, right? Not so bad. Is it entirely obvious how to match up these denominators? I would say not so much. There's no single number I can multiply x minus 1 by to get x squared minus 1. So this is where my hint from up above comes into play. Often we'll need to factor first to get a better idea of how to proceed. And because that's the kind of guy I am, we did a whole lesson before the break reviewing our special patterns. X squared minus 1 is just x plus 1 times x minus 1. That's just using our differences squared factoring. Can't apologize, everybody. It's just a tool we need in the toolbox. Should be automatic at this point in your math careers, because you guys doing this lesson learned it last year, reviewed it again this year. It just has to be in the toolbox. Now we can see how to proceed. If you want to add these expressions together, we need a common denominator. How can I make this first one look like the second one? I got to multiply by x plus 1. That will match them up. I got to multiply the top by x plus 1. So I'm using a different color. 1 times x plus 1. And I'm going to multiply the bottom by x plus 1 as well. X minus 1 times x plus 1 plus 2 over x plus 1 times x minus 1. Okay, this is the next level. We weren't just multiplying by a 2 or an x. We had to multiply by an actual binomial factor there. But now they match, and we can just add the tops together. We're just going to have 1x, and we're going to have 1 plus 2 is 3. We're done. Add the tops. It's adding fractions. We're done. X plus 3. Why 3? Because 1 plus 2 is 3. And on the bottom, x minus 1 times x plus 1. This time, we have two things that make the bottom equal to 0, plus or minus 1. Anything you guys want to chat about? That's some new tech for you guys. Can you guys apply the same idea to E? It's not really clear how we can make the bottoms match yet. But if you factor that simple trinomial, maybe your next sets will become more obvious. I think I'll work left to right first here to manage my space well. We're doing good, guys. Almost on level 2.
I don't think the denominator on the second fraction of E can be.
1 and 3. Yeah, I think it works.
But then try 1 and 3 and 1 it be 4 or 2x.
Let me just write it out. It's numbers that add to 1. Oh, you're right. We need a 2. Thank you. Or we need a 3 and... Yeah, what did I... okay. Yeah, please forgive me here. I made the same mistake last year, and I didn't fix it. And I probably won't the next time I teach the course. But as it is, this one can't be factored. So can we make that a -6? And then time travel back 90 seconds? Can you guys now try to proceed here? I think this should work. All right, so we get x plus 3, x minus 2. Aha! You guys get that as well once I fixed it? So now we can see how to match things up. This first term needs an x plus 3. So we'll multiply the top by x plus 3. And we'll multiply the bottom by x plus 3. And now we have matching denominators. And x minus 2 times x plus 3, it's the same as x plus 3 times x minus 2. It's okay if those orders are different on the bottom. Now here, where you can go right to where, if you're comfortable, you can go right to your answer. What we're really just doing is we're doing 5 times x and then adding x. We're doing 5 times 3 and adding 4. I have the space, so I will just show this intermediate step. But it's a bit of extra writing, so I'd be okay if you went right to the answer. That's 5x plus 15. Over x minus 2, x plus 3, plus x plus 4, over x plus 3, x minus 2. And now we can collect like terms. 5x and x make 6x, and 15 and 4 make 19. Over x minus 2 times x plus 3. Of course, we state our restrictions. X can't be 2, and x can't be -3. And if your order of brackets in the bottom is different, x plus 3 times x minus 2, it's okay. It means the same thing. As I mentioned, totally fine if you can just do that mental math. That to me, that's a reasonable thing to do in one step if you can visualize it. You don't need to write this intermediate step. All right, level 2 done. Level 3, guys, not so bad. The examples I've cooked up here, not too bad at all. Let's look at example set 3. 1 over x and 2 over 3. I can't multiply x by anything to get 3, or 3 by anything to get x. Remember, we have that trick, and there's no obvious common multiple. Just multiply the denominators together to get a good denominator that works. So I'm going to write this one this way. What does the 1 over x need? It needs a 3 on the bottom. So let's multiply top and bottom by 3. What does the 2 over 3 need? It needs an x. So let's multiply by x over x. We're just multiplying the denominators together to get a good common denominator. And in this case, that's just 3x. So we get 3 over 3x plus 2x over 3x. It's the exact same question, just reframed, rewritten with a common denominator. And now we can add the tops and bottoms together. 2x and 3 are not like terms. Resist the urge to mash them together into some monstrosity that doesn't obey the laws of mathematics. It's just 2x plus 3 over 3x. That's the best we can do. What makes the bottom 0 anywhere? X can't be equal to 0. We did it. Sometimes you got to multiply the bottoms together. Like in this one. There's no factoring that we could do here on the bottoms. There's no easy way to make x plus 1 to x minus 2 by multiplying. That's okay. Let's just multiply the denominators together to get a common denominator that works, like so. I'm going to write it this way. I think it's helpful. We can multiply the first guy by x minus 2 over x minus 2 plus 2 over x minus 2. The second guy needs an x plus 1 on the bottom. So I'll multiply the top by x plus 1 and the bottom by x plus 1. And the rest is just kind of grade 9 math. It's just collecting like terms and using the distributive law. So what do we have here? We have 1 times x minus 2 on top. On the bottom, we just have x plus 1 times x minus 2. This is a great talking point. There's no need to expand the bottom here. It's just fine as it is factored. No need to expand the bottom. On the top, what do we get? 2 times x and 2 times 1. So we get 2x plus 2 over x minus 2 times x plus 1. Now the denominators are the same. And we can just add the tops. I think I'll go right to the answer, just manage my space. X and 2x make 3x. And minus 2 and 2 add to 0. Okay, that worked out pretty good. We get 3x over x plus 1 times x minus 2. Of course, x can't be equal to negative 1 or 2. It makes those brackets 0. Yes, Andrew?
Is it right if you still expand the bottom?
It's technically it's correct. Yeah, there'll be spots in your 4U math course and calculus where you'll be interested in what makes the bottom 0. So having it factored is more helpful. Expanding it out again is more work. Guys, we did level 3. We're doing it. You guys are doing okay. Time for level 4. Here we go. Now, before we begin these, I will ask, when are we going to have to use these skills in the wild? I can tell you in 4U functions, you never have to do things like this. Wash your shirt. Yeah. But what we're doing is we're building up your skills. We're building up that strength. So when you get to the teeny tiny ones in grade 12 functions, they'll be a cinch because you've done the heavy lifting in here, mastering that skill. All right. Okay. How do I make these a common denominator? I can't see right away, but maybe I can factor these, and I believe they're not too bad to factor. Using our simple trinomial skills. Do I have space left to right to work? I think if I just use my fine motor skills, I think I can just go top to bottom here. Let's factor, and we can just breeze through the factoring here. Adds to 7, multiplies to 12, 3 and 4. How about the second one? Adds to 8, multiplies to 15, 3 and 5. Guys, these denominators have something in common, right? They each have and x plus 3 in common. What's this first one missing? I'd like it to look like the second one. What's it missing? It's missing an x plus 5, right? So we'll give the first term an x plus 5 on the bottom and an x plus 5 on the top. What's the second one missing? I'd like them to be common denominators. This one needs an x plus 4. So let's give it an x plus 4 as well. So that would look like the following. I have the luxury of using some different colors. You can do what you like, but this one on the left needs an x plus 5. It needs to have it on the top too, so that everything stays equivalent. So we have x plus 3, x plus 4, x plus 5 is our common denominator. And then we have on the right side, this guy needed the x plus 4. And you know what? I think I might just pop the x plus 4 in the middle there, just to put everything in the same order. We can do this. That's not so bad. A little bit of factoring, grade 10 stuff. Common denominator, that's grade school stuff. And now we have a common denominator, and we can just combine these two. I think we can just go right to the answer. We're going to have 1x minus 1x. That's 0. And we're going to have 5 minus 4. 5 minus 4, last time I checked, was 1. That was level 4. Are you kidding me? That's very manageable. I think you guys can do it. I believe in you. Of course, we state restrictions. We can't have x being -3, -4, or -5. That would make one of those brackets 0 on the bottom, and we can't divide by 0. I'm not trying to, well, I am trying to pump your tires. I believe everybody can do this. It's factoring, which is grade 10 stuff. We've been reviewing it. It's using our adding, subtracting fraction skills of getting a common denominator. And then it's just collecting like terms, which is grade 9 stuff. It's just everything is in one question. We can do it. Can you guys try B? Oh, I think we need to fix B as well. Can you guys make B x squared minus 9? Apologies. Apologies to future grade 11 math courses too, because I'm probably not going to fix that in my note. But if you guys make that x squared minus 9, this one here and this one here, they are the exact same question almost. Can you guys factor the bottoms? Can you figure out how to make a common denominator? I'll wait just a minute or so for you guys to kick the can down the road a tad. And I'll come along for the ride. Then we did it. Guys did great today. With the warm-up, took a bit. We've used up a lot of time. You guys are still going strong. Good job. All right, I am going to come along for the ride. I think I will, since I have the space to the right, I think I'll do my factoring over here. So adds to minus 7, multiplies to 12, minus 3 and minus 4. Plus, difference of squares, x squared minus 9, x minus 3, x plus 3. Aha, it's now more clear how we can make these denominators common. The first one needs an x plus 3. Unlike A, this time on the top, when we add in the x plus 3, we are going to have to expand and collect like terms to do our simplifying. On the bottom, we have x minus 3, x minus 4, and x plus 3. And a nice thing, we are recording today's lesson, so you guys have the luxury of going back and rewatching these later. What does the second one need? The second one doesn't have an x minus 4. We need to give it an x minus 4. And I think I'll just make them in the right order right away. We can do it. Nothing here is brand new. We factored the bottoms, and we used our adding fraction skill of finding a common denominator. We filled in what each one needed to get a common denominator, and now it's just a matter of collecting the like terms on the top. And yes, we will have to expand this one and expand this one before we can collect the like terms together. That's okay. We'll just grind it out. We got the space, so x squared, we got a plus 3x, we got a plus 2x, and we got a plus 6. And on the right, we got x squared, we got minus 4x, we have plus 1x, and we have minus 4. And then we have a bunch of like terms to collect on the top. Let's wrap it up. X squared and x squared, 2x squared. 3x, 2x, minus 4x, and x. I believe that adds up to 2 in total. 3 plus 2 is 5, minus 4 is 1. Yep. And then 6 plus negative 4 plus 2. All over x minus 3, x minus 4, x plus 3. We did it. Of course, there are some restrictions. What makes the bottom 0? Plus or minus 3 or 4. That's level 4. That's basically the level we need to get to handle anything in our future math courses, at least at the high school level. I got to say, 3U people, you guys took that like champs. This is a skill that we need to practice. If you've been getting away with not doing a lot of work outside class because we've been doing a lot of review, or what we've been doing has been feeling pretty good, this is something you might need to invest. You might want to invest some time in outside of class, making sure you practice as much as you can. I want to remind you guys as well, when you're practicing at home, like let's say you're doing 9A and you're unsure how to proceed, bring up PhotoMath, bring up ChatGPT. That is not cheating when you're at home practicing to help you get unstuck. It can help actually be a great tool. Or come see me for extra help. I'm pretty sure that the number of times anyone's asked for extra help outside of class in this course is 0. I'm pretty sure it's still 0. So I'm happy to help. After this class, I'm done teaching. But I'm rambling. It's time for you guys to practice. These questions are all like set 3, and these guys are all like set 4. What will you need to do on your unit test for Friday? Basically a copy-paste, this kind of thing. I won't give you guys anything else really different. You got to factor, you got to find a common denominator, you got to collect like terms on the top. I believe in you guys. So let's get practicing. I'm here to help if you have any questions. 3M people, thank you for your cooperation. I'd be happy to help you if you have any questions as well. If you'd like your cheat sheet to add some things. Hey, listen, everybody in the class right now, for the most part, I'm not concerned about attendance. I'll let you keep your cheat sheet if you want at this point. So how about I just give you guys your cheat sheets? Then I don't have to hang on to it. Yes. Yep. 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 3 over 2 is like 1.5, right? If you divide 3 by 2. And you can see you 2 times 1.5, that's 3, and then 3 minus 3 is 0. So it does check. Right, no color, no clear.